Alright, we're going to deal with congruent triangles. Alright, congruent triangles are two triangles where corresponding sides are congruent and corresponding angles are congruent. We can help figure out which angles and sides are corresponding by looking at the congruency statement. That's usually in the top sentence of many questions that deal with congruent triangles. So here we have GHJ. G will correspond with X, so they are matching angles. H is going to match with Y, because they're both in the middle of the name. And angle J is going to match with angle Z. So we can see which ones correspond to each other. So to the right, it's asking us to write down some missing sides and angles. So the first thing they ask for, what is GH, side GH? So side GH is right here. Now, in a lot of pictures, you can generally tell what sides actually correspond to the other triangle, but if you ever have trouble, just use the congruency statement. G and H, first letter, last letter. That's going to match to X and Z, the first letter and the last letter of the other triangle. Therefore, ZX, that length, is the same as GJ. Next one, part B, XY. So XY is right here. And once again, you can use the congruency statement. XY is the first two letters, so it's going to correspond to the first two letters, GH. So GH is 27, therefore XY is 27. ZY. ZY is the last two letters, so it's going to match the last two letters in the other triangle. So ZY is going to match HJ, and we can see that HJ has the congruent mark to its other side. So the length of HG is the same as HJ, which therefore is the same as ZY. So we can use that same principle that we just dealt with for its sides with its angles. So they want to know what angle H is. Well, angle H matches up to angle Y. They're both the letter in the middle of each triangle. So angle Y is 38 degrees, so angle H is 38 degrees. Angle Z and angle J is the next one they're looking for. If we look at the first triangle on the left here, we have these two congruent marks, which means this is an isosceles triangle. So if these two sides are the same, their opposite angles are also the same degree. Well, how do we find out what that degree is? Well, if they have to be the same number, we're asking ourselves, if a triangle has 180 degrees, we know 38 of it is H. I'm going to subtract that away. So 180 minus 38 is 142. So out of these 142 degrees left, these two numbers have to be the same. If I divide this number by 2, I'll get two numbers that are identical. 71. So that's saying 71 plus 71 plus 38 is 180 degrees, where these two are the exact same number. And once again, they're the same number because we had an isosceles triangle, and an isosceles triangle is identified by having two congruent sides. So the two angles that are opposite of those sides have to be congruent as well. All right, so this is asking a few different questions. It's given us the congruency statement that triangle ABC is congruent to DEF. The first question is, what transformation was used to create triangle DEF? Well, our options are going to be a rotation, a reflection, a translation, and a dilation. Now, since we have the congruency statement, there's only three transformations that make congruent figures. That are these three. These create congruent figures. A dilation creates a similar figure, which means it would look the same, but one is much larger or smaller than the other. So our options are these. How can we tell which one it is? Well, most of you can probably eyeball it and be like, oh, it's this, obviously. You can notice that angle C and angle F are the same. So if angle C is here, angle F is here, notice how the 90 degrees is over here on the left, but now it's up here at the top. And that's because they're rotating the triangle. It's doing a rotation. Because you can see how it turned on its side. The next one wants us to solve for x. So to do that, we need to figure out the corresponding sides. So here we have, this is where x is located. We have a 2x minus 2, so AB. I want to find the side that corresponds to it in the other triangle. So AB is the side we're looking at, which means in the other triangle it matches up to DF. First two letters, first two letters. So these two lengths are the same, and if they're the same, you can set them equal to each other. We just add the 2, you get 8, divide by 2, and you learn x is 4. All right, the next thing they want us to find is the measure of angle F. So angle F is using the last letter, so the last letter. So we do not have information provided to us at either one of those angles. So we have to do just a little work. In the triangle ABC, they give us 2 out of the 3 angles. They give us the 90 degrees here and the 53 degrees here, which means using the triangle sum theorem, we can figure out what this last angle is by doing 180, subtract away the ones that you do know, and what's left over would be that angle. So this is going to be 39 degrees. So if 37 degrees. And if that's 37 degrees, then its corresponding angle over here is also 37 degrees. All right, so this one's asking us to solve for x and y. They give us a rectangle, and we can see they drew a diagonal line from A all the way to C. And they're letting us know that there are 2 triangles here. There's triangle A, B, C, and then there's triangle C, D, and A. They want us to solve for x. You'll notice that A, C is in both triangles, which means that the length of 81x plus 88 is representing the same line as the 2113, which means we can set them equal to each other because they're talking about the exact same piece of our triangles. So we can go we can do 81x plus 88 equals the 2113. And then we go ahead and we solve. You just minus the 88 over. So you have 2113 minus 88, and you're going to get 2025. From there, you can go ahead and divide both sides by 81, and you're going to get 25 for the x. Solving for y. So we can see, looking at the picture, that this right here, this angle, and this angle are going to be congruent. And the reason why that is if these are 2 triangles at 90 degrees, you've essentially made a rectangle, which means they're parallel to each other. And this is what we call a transversal. So this right here is going to be congruent to this one right here. because these are called alternate interior angles. If you look at your formula sheet on the front page and the bottom left, you'll see that being described to you. So those two angles will be the exact same degree. And we just go ahead and we solve. We're going to have to do a little reducing. Reduce by 5. So we're going to have 5 reduced by 5. You're going to get 3. All right, two congruent triangles. You can prove two triangles are congruent given these different theorems. So the first one is SSS. That's referring to side, side, side. So if you can show that the three sides of one triangle are the exact same length as the three sides of another triangle, you can prove they're congruent. As an example, this was 5, 5, and 10, and if this was 5, 5, and 10, then you can prove these are two triangles are exactly the same. They are congruent. The next one is side, angle, side. So if you have two sides, say this is 3 and 3, and you have this angle, which is, say, 30 degrees, and in the other triangle, you have a length of 3, a length of 3, and this is 30 degrees, you can say these two triangles are going to be congruent by side, angle, side. You don't need to show that every single part of the triangle is congruent for you to say that they're congruent, as long as you have a side, an angle, and then another side. The third one is angle, side, angle. So if you have, say, this is 40 degrees, this is 50 degrees, and let's say this side right here is 10, and if this one is 40 degrees, 50 degrees, and this side is 10, by having an angle, a side, and an angle that matches the other triangle, angle, a side, and angle, same numbers, 50, 50, 10, 10, 40 degrees, 40 degrees, then you can say they are congruent by angle, side, angle. The next one is angle, angle, side. So if you have, say, this is 60 degrees, this is 50 degrees, and then this is a length of 12. And if this one down here is 60 degrees on this angle, 50 degrees at this angle, and this side is 12, you can say that you'll know that these two triangles are congruent because of angle, angle, side, angle, angle, side. So their corresponding angles match up, and that corresponding side matches up. The last one is HL. HL is referring to hypotenuse leg, and that only applies to right triangles. So if you have two right triangles, and you can show that, say, this leg is 5, this leg is 5, the hypotenuse is, say, I don't know, 13, and this is 13. If you can notice that it's a right triangle and corresponding legs here are congruent and the corresponding hypotenuses are congruent, then you can say for certain that these two triangles are congruent. All right, so it says determine if two triangles are congruent, write the theorem or none of information, and then write the congruency statement. So here for part A, we have two triangles. We have this one right here and this one over here. We're going to look, we can see that we have an angle, a side here and a side here marked in red. So we have EB is congruent to BD. So we know they are congruent. They don't have anything else marked, but there is one more thing that is congruent in this picture that isn't labeled because they expect you to know it from earlier in the year, and that's vertical angles. So this angle right here and this angle right here are also congruent because they are vertical angles, and vertical angles are congruent. So angle ABE is congruent to angle CB and D. Now they have provided a side and an angle, but there's nothing else there. So it doesn't match any of our theorems we have listed in our directions. So this is just not enough information. You can't prove these two are congruent triangles given what's provided. If we look at part B, you'll see that they provide a angle A is congruent to angle E. You can see that this side right here, AC, has the congruent mark with EF. So side A, wow, I can't write. Angle AC is, sorry, not angle, side AC and EC are congruent because they have the congruent mark. And don't forget, once again, vertical angles are right here. These two angles right here are congruent. So angle ACB is congruent to angle E to C to B, or sorry, to D. So we have a angle, a side, and an angle, and that matches up with this theorem right here, angle, side, angle. So we've proven these two triangles are congruent by showing that they have a angle, side, and then an angle that corresponds in each triangle. So our next one, same directions. So in this one we can see that this side AB is congruent to HK. We can see that angle A is congruent to angle H because they have the congruency marks. And then once again, don't forget the vertical angles. So angle ACB would be congruent to angle HCK. These two vertical angles. That means we have a side, a angle, and then another angle. And that matches up to this one here. Two angles and then a side in that order. So it doesn't matter if it's AAS or SAA. It's going to be able to prove that they are congruent by AAS. Our next one, you can see we have the 90-degree angle here, 90-degree angle here. This is talking about right triangles. Since we're talking about right triangles, our options for it to be correct is HL or not enough info. So we have to see, do they have a leg that's congruent, and do they have a hypotenuse that is congruent? So here is the leg of the triangle that I'm marking in purple, where they have the two congruent marks. So yeah, we have the leg. DC is congruent to BC. So there's our leg. Do they have the H? So remember, hypotenuses are directly across from the 90-degree angle. So AC is the hypotenuse of that top triangle. And here's the other 90-degree for the triangle that's in this below. Its hypotenuse is also AC. Since AC is congruent to AC, there's our hypotenuse. So yes, we can prove they're congruent by hypotenuse leg. All right, our next one. So we have two angles marked, and they don't have anything else labeled. Since there's two angles marked, our options are essentially angle, side, angle, or angle, angle, side, because they are the two that have two angles in it. Or it could be not enough info. So it could be this one. So we have to see, is there a side that is congruent? Well, both triangles are touching each other at the side AD. They're overlapping, which means they're the same length. So in reality, we have an angle, and then a side, which matches this one right here, angle, angle, side. And the next one, we have these two sides here being congruent. So DC is congruent to AC, so we have a side. We also have another side over here, AB is congruent to DB. And then there's one more side that's actually congruent, that's BC. BC is on top of each other. And since they're in both triangles laying on top of each other, there is our other side. So side, side, side proves that these two triangles are congruent.